China just launched a new humanoid robot girl with one feature nobody expected. The world's largest cargo drone just had its first successful flight. A trillion-parameter AI from a phone company is now competing with the best models in the world. And a military helmet that sees through concrete walls is about to hit deployment. Stay with us. Today's stories are worth your full attention.
A Chinese company called Warmcore Tech has just introduced a humanoid robot girl named Xiaoling. She weighs about 75 kilograms, moves around on its own base, and can operate in malls, offices, and exhibition halls without assistance. That part alone sounds familiar, but here is what makes Xiaoling different from every other service robot you've seen before. Its head is swappable. Warmcore built Xiaoling with 4 interchangeable heads, each designed for a completely different role. One head is tuned for friendly retail interactions, another for technical product demonstrations, and another for more personal companion-style engagement. Each head carries its own sensors and cameras. This means one robot body can shift between guiding a visitor, scanning a product, and tracking someone's facial expressions, depending on which head is attached. For businesses, this is a significant change in thinking. Instead of buying several specialized machines, a single robot can be reconfigured for whatever the moment requires. That is not just cost efficiency, it is the beginning of a new category. Robots that are not built for one job, but built to adapt. And that quiet shift in design philosophy is worth paying attention to.
But that is only part of the story, because while one company is rethinking robots, another is rethinking how we build the places those robots will eventually work inside. Icon, the American construction technology company, has unveiled its most ambitious machine yet. It is called Titan, and it is a mobile 3D printer for buildings. Unlike earlier models that were fixed in place and required days of setup, Titan moves on its own tracked base. 2 operators can have it ready to print within 2 to 3 hours of arriving at a site. The numbers are striking. Titan's robotic arm spans 70 feet, can print structures up to 27 feet tall, and is capable of covering 12,000 square feet per floor. A 2,500 square foot home can be printed in under 7 days, at roughly $20 per square foot for the wall structure alone. Think about what that means in the context of a natural disaster. After a flood or earthquake, one of the biggest challenges is not clearing debris, it is rebuilding shelter fast enough. A machine like Titan can move from site to site, printing affordable housing in sequence without the delays of traditional construction. Icon has priced it at $899,000, with training beginning later this year and deliveries starting in 2027. This is not a concept, it is a machine with a price tag, a delivery date, and a very specific problem it is designed to solve.
Meanwhile, something much simpler is already out in the world, and most people walk right past it without a second thought. In China, over 1,000 solar-powered street benches have been installed across cities, with 16 new ones recently placed along public walkways in Guangzhou's Baiyun district. At first glance, they look like ordinary park benches, but sit down and you will find USB ports, wireless charging pads, free Wi-Fi, LED lighting, and an ultraviolet mosquito repellent system built right in. What appears to be city furniture is actually a small piece of urban infrastructure. These benches run on high-efficiency solar panels and store energy in lithium batteries, meaning they operate through the night and even in low light conditions. They reduce dependence on the power grid while adding connectivity in places where it previously did not exist. It is a quiet reminder that smart city technology does not always arrive as a dramatic announcement. Sometimes it just shows up as a bench.
And while cities are getting smarter at street level, the race to lead in artificial intelligence is getting sharper at the top. Xiaomi has officially revealed its flagship AI model called MiMo V2 Pro. It carries over 1 trillion parameters in total, with 42 billion active at any given time through a system called Mixture of Experts, which routes information efficiently rather than processing everything at once. The model can handle 1 million tokens of context, meaning it can read and reason across extremely long documents or conversation histories without losing track. What is interesting here is not just the technical specs, it is the positioning.
Xiaomi's model is being benchmarked against Claude Opus, one of Anthropic's most capable AI systems, and it is scoring comparably at significantly lower operational costs. For a company best known for consumer electronics and smartphones, entering the top tier of global AI is not a minor footnote. It is a direct challenge to the established players. The model is currently available through an API and powers a family of related tools, including voice and multimodal variants. The broader implication is that serious AI capability is no longer exclusive to dedicated AI labs. Device manufacturers are now entering the competition with real contenders.
And then there is a story that carries weight well beyond any product launch. On March 31st, China completed the first flight of the Chang'e 8, the world's largest cargo drone. The aircraft has a 25-meter wingspan, weighs 7 tons at takeoff, and can carry a 3.5-ton payload over 3,000 kilometers without refueling. Its cargo bay is large enough for standard shipping containers and can be fully loaded in about 15 minutes. It takes off from short runways, as little as 200 meters, which means it can reach places that larger aircraft simply cannot. This is a turning point that deserves careful attention. The Chang'e 8 is not just a logistics tool. It represents a tested, production-ready solution to one of the oldest supply chain problems, reaching difficult terrain quickly in a crisis. Flood zones, mountain rescue operations, remote islands with no road access. These are the places where speed and reach determine whether people survive or do not. The drone is now moving toward mass production, and China's logistics sector is already watching closely.
Not far behind in the drone conversation, though from a completely different direction, is Japan. A startup called Air Kamui has built a drone out of cardboard. That sentence sounds like a joke, but it is not. The drone flies at 120 kilometers per hour, stays airborne for 80 minutes, covers 80 kilometers, and carries payloads of up to 15 kilograms. It can be assembled in 5 minutes without tools and is waterproofed for real-world conditions. The irony is hard to miss. At a time when the drone industry is investing in titanium, carbon fiber, and proprietary hardware, the most disruptive innovation might be a folded sheet of treated cardboard. Because what cardboard gives you is scale. Thousands of units can be manufactured quickly in ordinary factories at a fraction of the cost. For disaster response, border surveillance, and training programs, disposability is not a weakness, it is the entire point. Air Kamui raised 100 million yen in 2025 to scale production. The future they are building is one where drone swarms are not expensive assets to be protected, but cheap tools to be deployed by the hundreds when needed.
And looking further ahead, the question of how technology changes the experience of the individual soldier is now becoming very concrete. Anduril Industries, working alongside Qualcomm, Meta, and Oakley, has developed a helmet called EagleEye. It is an augmented reality system that pulls in feeds from drones, satellites, ground sensors, and cameras and overlays them on a soldier's visor in real time. Threats behind walls, ally positions across terrain, a 360-degree view from sensors mounted at the rear. All of it visible without needing to stop, look down at a device, or radio for updates. The first 100 units are set to deploy in mid-2026 under a $159 million Army contract. What most people are not seeing yet is the longer arc. EagleEye is not just a better helmet, it is a glimpse of a future where the gap between what a soldier can perceive and what machines can sense is closing rapidly. Human decision-making enhanced by machine awareness. The consequences of that shift, military and ethical, are only beginning to be understood.